eventually you'll get wherever you deserve. So with that, I'll just reiterate. I've worked with companies like Meta and Amex. I started actually in a small consulting firm first couple of years of my career. Later, that was acquired by Cognizant. Then I moved to Amex. I stayed in Amex for almost 10 years. Halfway through, I moved to USA about 10 years back from within Amex. And then when I left Amex in 2020, I was leading a team of about 15 people. After that, I joined one startup as a CXO as well for a bit. And then eventually, I was not uh, feeling, a right fit. So I went to Meta. That was a bit of a career change from my point of view. I moved from, financial or I started from consulting, moved to more like financial analytics, and then moved to application of data science into youth safety. How do I save the youth on Instagram? That was a unique problem to solve. And then last almost 3 years now, I've been at DoorDash. DoorDash, for some of you who may not be aware, DoorDash is, imagine like, I don't know, 10, 20 times higher, bigger version of Zomato. So it's like a food delivery platform in US. And I lead about 10 people team here. I'm a senior manager here. So that's about me. Just want to now also give you context into data science as a profile, and then we'll move to the SQL part of it. So data science or analytics, or depending on the company, depending on the organization or education institute, different people mean slightly different things with this different names. So it's always good to ask exactly, let's say when you're applying for a job and job title may be like data scientist or business analyst or whatever. It's always good to kind of clarify like, hey, what are the exact requirements that you have from the skill point of view, and what are the exact outcomes that you're going to drive, so that you can figure out on your own like which company says business analyst and then expects you to learn like SQL, Python, visualization and everything, versus someone says like, hey, only data science, but you can still survive with just SQL. So just one caveat, especially when you're going into your interviews and as you start your career. So always clarify like what exactly it means, because titles can be anything in different companies. I can definitely say that I had a much bigger title when I was at Amex. I left Amex when I was the director of analytics there, and then I joined Facebook. My title was like data scientist. I can tell you like my salary was at least two times in Meta, and my title right now is senior manager, but I'm pretty sure I earn probably three times more than even CEOs of small companies. So that's why I'm saying that as you start your career journey, don't get stuck into titles. Focus on skills and focus on outcomes. That's gonna take you longer. Just one last point on data science and analytics as a field. As you guys might be figuring out, like, what's the right path for you, consulting and analytics and whatnot. See, these things are kind of merging as well as we grow. Data is kind of becoming a hardcore requirement across industry, across profile types. So as you graduate, things will change more and more. And SQL is something that I believe is becoming more of a necessity. It's like, using Excel or using PPT, like everyone has to do it. Doesn't really matter whether you're in consulting, iBanking, or like any other job as well. Like it's such a basic tool that everyone needs to learn it. SQL is kind of increasingly becoming that kind of a tool. Obviously, I'll tell you like, what kind of skills you should gather while you can, depending on the profile you're focusing on. So with that, let me move to what is SQL. So I'm just going to cover a few basic things today because it's not like a SQL course in itself. We just have like 45 minutes or so. But I want to give you all the quick nuggets and main, like pro tips for interviews and etc. so that you have all the resources at your disposal to actually learn about SQL. So we'll talk about what is SQL, what is the application of SQL in business analytics, what is the things that you should be learning in terms of basic and advanced functions, and some pro tips for interviews that when I conduct interviews, even with there's a practice in data science and in big tech companies like Meta, DoorDash, Google, Amazon of the world. Like it doesn't really matter which level you're coming in. We conduct one SQL round for all data science track. and we see that a lot of very experienced, very knowledgeable people fail that round because they just are not very hands-on and they make like basic mistakes. So I've covered those pro tips for interviews, so learn those things. You'll sound smarter in interviews. Okay, so SQL is nothing but a programming language designed to manage data stored in a relational database. I know I said relational database, manage data, etc., etc., but I'm pretty hopeful that this group is already elite group, a lot of young as well as talented students. So hopefully you already understand these things. Very basic. Imagine a table. That's all it is. SQL is just a way to understand the tables and basically relate insights or get insights from multiple tables. That's all it is, right? So relational database, nothing but a store of data organized in tables. Um, so it may sound very easy to do. It is frankly fairly easy to do as well, but it just pays very well if you really do it very well. So with that in mind, um, very basic concepts about data that everyone should know, like what is the primary key of the table, what is the column type. All these things might sound very, very preliminary, and you guys are like IITians and whatnot, like you might feel like what the hell is it? It is very simple. It is like elementary math or elementary basic concepts. It is not a rocket science. um, but rocket scientists get paid very less compared to what you're going to get in consulting or analytics. So what it means is that just learn these basics, but learn them very, very, very well. That's about it. So fundamentals of table, how to read them, that's all SQL is. I have included some online SQL resources rather than extracting all the information in the slides. I've just given you the direct links, and in the order of like my view, like what should be a good starting point, etc., etc. Even if you look at like SQL board, I think it has structured the lessons very, very well. Depending on your speed, it might take anywhere from like a couple of days to like a month or 2 months to learn SQL. Just do it. There is no way around it. uh, Top companies in the world, like Metas and Googles and Amazons of the world, uh, even from pay perspective, DoorDash and Netflix of the world, they don't go beyond SQL bold kind of questions. So you don't have to learn like everything on the internet. Just focus on like one or two good links, one or two good courses, and that's about it. Just do them properly. So I'll pass these slides to you as well, so that you can have these links handy. Um, Other than these, you can always pay for variety of courses. I in my life hardly have ever paid for any course because everything is available kind of on YouTube or some kind of a website. But I'm not against of paying for any course. If you think like there is a structured course out there, there is a good instructor who can deliver the content in a better fashion, go ahead. I've only included free online SQL resources that I found useful. Okay, now application of SQL in business analytics. So let me spend like a few minutes here, like why exactly SQL is required and what is the use, and I'll give you very real life examples. Um, so first of all, the basic SQL, like basic syntax understanding, basics of how to pull the data the way you want, etc. That is something is becoming essential for everyone. I am in a data science role. Typically, all big tech companies are structured. Uh, like Meta, for example, Meta was structured like there was an engineering org, there was a data science org, and there was a product org predominantly. So product managers would figure out like what kind of features, what kind of products we need to build. Data science engineers would actually build those features, and data science would be like somewhere in between. It will be the truth teller of the team. It will support the product manager or help the product manager uh, validate some of the hypotheses that they have, set up experiments, and figure out like whether what we learn from experiments, does that validate the hypothesis or reject the hypothesis, and so on. And then also help on building like some of the machine learning and AI algorithms, and then engineers would actually use those basic algorithms and literally implement them or build the software features around that. So what I'm trying to say is that even if you're a product manager or in DoorDash Parlay, there are product managers as well as some operations or strategy managers, mostly ex-consulting like ex-Bain, BCG, McKinsey folks. So even operations guys like, all my friends or colleagues or senior colleagues that I've worked with, including some of the CEOs of, fairly large companies who used to be, my ex-colleagues, they generally, came from either product or operations or because they are business people. But the top people that I've worked with, they have basic SQL knowledge because SQL allows you to be independent so that you don't have to wait for a data scientist or an analyst to actually pull the data for you. You can yourself pull at least the basic data and validate or invalidate your own hypothesis about business. And trust me, I have seen it, over and over again that after a few years in the industry, it doesn't really matter whether you're coming from a high-end consulting or iBanking or whatever. If you don't have basic programming, especially SQL, you will feel stuck. You will feel dependent on your team. You'll feel dependent on your colleagues. You'll feel dependent on some other partners. Same thing happens for engineering track as well. So that's why, as I said, SQL is becoming kind of a necessity, not just for data science or data engineering profiles. We are now kind of, requiring SQL, at least basic SQL, even for product managers and operations people as well. So hopefully, for better or worse, it is going to become like a necessity if it's not already. For advanced roles like data scientists and data engineers, more so for data engineers, like even advanced, like all optimization concept around SQL are a must because that's the job. Even for data scientists, like there is obviously MLAI part of the job which requires you to code in Python as well as have a lot of understanding about MLAI features. But trust me, even if you have to build a model, I've built like variety of models in my life in 15 years, ranging from like models helping allocating Salesforce to like predicting defaults in a banking fashion or just honestly from Facebook or Instagram terms, literally predicting what do you call it, like vulnerable youth on the platform or pedophiles, for example. I have predicted that as well. So all that, it definitely requires like a lot of MLAI concepts. But trust me, 80% of the job is just to clean the data, and that requires SQL, extensive SQL. So if you know SQL by heart, then 80% of the job is already done. Trust me, you'll sail through in your career very beautifully just by learning this basic thing. With that, I want to voice over a few concepts. I know some of you may already have learned SQL, may not. That's okay. If I were you, and with this kind of 15 years of experience, I would actually start early. I would start learning this in college itself, so that by the time I join a job, I'm already through with the basic concepts. In reality, I actually learned it in my first week of the job, first couple of weeks of the job. That's all I required to learn the basics and part of the advanced as well. And rest just came with with the job. Even today, I have like 10-member team. I have a lot of leadership responsibilities. Um, I work with the CEOs and CXO teams directly. I still find time to write my own SQL, to get my own data, to do my own analysis, and that's a good practice to have. Doesn't really matter how senior you become. Always make sure that you're hands-on, and that will always, take you further than someone who is not hands-on. Okay. With that, basic concepts, table structure, data types. I'm sure you must have already read this in your DSA or whatever courses you may have at college. If not, just use the free links. That's about it. Understand the general structure, understand like table operators, like how to create a table, delete a table, drop a table, take a union, etc. Sounds very easy. It is very easy. Just don't make silly mistakes. Just understand what's the right syntax. Just understand like why it is happening, because syntax is still something you can get from chat gpt or whatnot. And then more and more tools are coming. Organizations such as Meta and DoorDash, they have their own internal versions as well, which are pretty good. But trust me, when I was at Meta, the best practice there was that every code in the organization was shared, so I can literally see what other person is doing, and probably don't even have to ask them. And there was a wrapper around it. Like ChatGPT is now public, but 3 years, 4 years back, we had our own version of ChatGPT within Meta, and I could literally get the code that I want, but the skill was required to debug it. You can get the code, but how do you know whether it's right or wrong unless you know the basic concepts? So ChatGPT is not going to help you with that. Any kind of AI is probably not going to help you debug, and that's why you need to learn at least the basic concepts. So basics about tables: create, delete, drop, union, all, etc., etc. The differences between them, and trust me, it will be required eventually in the job or in the interviews. How to aggregate the data, uh, mathematical functions like min, max, count strings, count, etc. Uh, some There is a concept around null. Uh, so null values, how to treat the null values, how are they different or not different from blank values, or other numeric or character values. So definitely area where I've seen a lot of mistakes over 15 years. So definitely read them, definitely understand those mistakes are and avoid them. Then there are concepts around group by, having, order by, limit. Again, very basic concepts. Group by is literally what it means, like grouping by something and then having like an aggregation of min, max, count, etc. So literally, it's a very simple language, SQL. It's like literally speaking English. So that's about it. Like having, order by, limit, uh, and or, between, in, like, all these are very very basic functions. Initially it may feel daunting, maybe, just to put it on one slide, but once you spend like couple of days on it, you'll start having a hang of it. And do it early, do it now, because sometimes what happens is that you guys, I see this time and again, like very very good candidates from IITs and IIMs, and even in US, like Harvards and I don't know, like Ivy Leagues of the world. They learn so many complex things, and then when I ask them basic stuff, they kind of forget it, and it's just a no-no, from interview point of view, because like we're not really solving rocket science problems in any company. In a professional environment, we're solving business problems, which are honestly not very complex. They're ambiguous, but not very complex. So we need someone who is solid with the basics so that they can solve an ambiguous or a new problem rather than solve a tough problem. So understand the difference between an ambiguous and a new problem versus a tough problem. IITs or top institutes in India, even in Ivy Leagues here, we have a bias of solving the toughest problem and not bias towards solving smaller problems and then keep solving them in a efficient way. So that's where I think you guys, uh, since you're already in college, you start training your brain slightly differently as well, because in real world you'll actually get paid more for solving a smaller, solvable, ambiguous problem which no one has solved before, rather than solving very, very tough problems. Okay, coming back to SQL, some of the advanced, concepts like case statements, joins, left, right, full, self. Again, I would say SQL Vault or other lessons, they will give you very good sense how to join the tables. Literally, join means like joining the tables. But how do you join it? Like left, right, full, or self. Left, right is nothing but like if it's a left join, like table A versus table B, you keep all the information from table A, but like only limited information from table B, which joins with the table A. Right is like vice versa of that. Self join is a very tricky concept, like table join with itself and then interpreting the information differently. That's where most of the complex interview questions come from. It's called self join. If you are appearing for an interview, just learn about self join, Google it, ask, do a few questions yourself. It's just one table, but the kind of information that you need from that table, it has to be joined with itself, and then some operations have to be applied. This is one of the uh, smartest question to ask from interviewers point of view, and easiest, but at the same time very complex. It becomes complex for for interviewees. So that's an area you should always focus on. um, I think in my first year of job or second year job, I failed one or two interviews because I was confused with self join. Eventually, I learned it. So just do it. Subqueries with again a bit more advanced concept, like how do you extract some data from a table, kind of treat it as a separate table, and then again join it with the main table or another version of it. So there are various ways of writing it, either in a subquery or either with a statement. Um, so this is also very favorite of interviewers, like they want to see, like, are you able to subquery or write a with a statement. Either way it works, but you should know how to extract information from a table and store it in another table, and then be able to treat that as a separate table and then merge back with the original one. Then there are again few concepts like rank, lag, lead, etc. Again, it might sound like I'm just reading through a slide, but trust me, this is like my 15 years of experience. These are exactly the kind of questions that jobs which offer $1 million for the annual salary will ask. Sounds very simple, but people still make mistakes. Case statements, join, subquery, rank, lag, lead, percentile. Mostly, that's all the toughest of the questions. You will be able to solve for any FANG company or for any top profile within data science analytics you're looking for. One thing that gets talked about less is query optimizations within the advanced, especially for data engineers, not so much for data scientists. Ideally, for data scientists too, depending on which company defines data scientists how. In big tech companies, data scientists are rarely expected to do data engineering job, like just building ETLs or tables or big tables and so on. Generally, there are data engineers, but some, like in my career, I have had different titles, and I've kind of done all kind of jobs, like including data engineering job. And trust me, all these query optimization concepts will help you just expedite your analysis, because if you write from job point of view, if you write query in a very bad fashion or inefficient fashion, I mean, you'll get the right answer. You'll just take a long time to get it, and then you'll see that in real life, as I said, it's not that you're trying to solve a tough problem. You're trying to solve a simple problem, but speed is essential. So query optimizations, always try to write the same query in its smallest possible way, not just from writing perspective, but from runtime perspective as well, um, to the extent possible, because this will help you eventually to give the answer faster, so that your leaders, your partners can make the decision faster. All right. With that, let me move. So I've shared few basic concepts and advanced concepts. Again, if you're planning to move into, core consulting or core strategy profiles, even then, I would advise you to learn the basic SQL concepts. It will just help you outshine your peers. And if you are trying to get into hardcore analytics and data science, data engineering kind of profiles, then definitely advanced SQL is something you will anyways have to learn. So why don't you do it sooner than later? Um, and again, my recommendation advice would be not to spend unnecessary money, especially now, you guys are all students, on any paid course. But unless you find really good one, and it's reasonably priced and so on, uh, focus on free resources. I think they have structured very well already. There are a lot of exercise form questions as well. It will help you learn enough. And once you get a job, always try to find opportunities. If you find a job like in business analytics, then definitely you'll get a chance to work on these. One more experience I want to share. I was helping a CEO a couple of years back, or year and a half back. It's a dear friend, uh, CEO of a company called Skipkart in US. They have a business in like 50 cities here. Think of it like blanket kind of a company in US. Um, I was helping him hire out of friendship, like no professional this thing, but I was helping him hire some data professionals, and my idea was like, hey, why don't you hire in India, and maybe I can help you hire a few good folks, and then that way, it would be cost effective for you, and you otherwise you're gonna have to pay a lot of money in US. So I was trying to pitch India brand. Unfortunately, and that's an experience I wish I didn't have. Unfortunately, when I interviewed, bunch of candidates, at least 5 or 6 candidates I interviewed within a couple of weeks. Uh, they all were like 2 years experience. Were expecting kind of, if I remember correctly, it's been quite some time, but they're expecting 25 lakh kind of a package, and that's reasonable for a 2 3 years of experience in data science or analytics. That's very reasonable package. They were around 15 18 at that time, but they just didn't have the skills, like. And unfortunate part was that a lot of them didn't even show that, uh, what do you call, like fire in the belly to learn that skill. And that's where it broke, like, and then the CEO decided, like, what, let's junk the India plan. I'll probably pay more. I'll probably pay 50 lakhs or 80 lakhs or whatever, 1 CR, and then equivalent whatever in USD, and hire someone in US. I wish that was not the case. Part of the reason why I love to, come to such talks, so that, I can motivate folks that, hey, um, uh, this is not very complex. This will get you good salary. This will, like, make sure not just you are progressing in your career, but, like, as you progress, India progresses. As you progress, the world progresses. I think it's a win-win for all of us. Even when I'm sitting in US, or even when that CEO is running a company in US, it is more efficient for them if they can find, same kind of a skill set in a more affordable way. And then India has a play there. I just feel like sometimes there's a bit of a gap in terms of skills, and I hope that these kind of presentations bridge that. Uh, with that, let me quickly move to the pro tip number one. This is probably the most fatal flaw that I've seen, and this is like a no-brainer, rejection. Like, someone makes this mistake, and I'm like, okay, they don't understand the basic concepts, and I literally reject them. I have done so like hundreds of times in the last 15 years. Uh, I know most of you haven't learned about SQL, but when you do, you'll understand this more clearly. Very simple left join. Uh, when you do it with a where condition, it just makes it an inner join. So think of it like inner join is nothing but interact A and B. So uh, a lot of people do that. They write left join, and they think that they are writing A union B, like, so everything from A, but only, corresponding things from B. That's what they think they're writing. So table A is 100 records, table B is 10 records. They're writing a left join. They're thinking like, hey, we'll have all 100 records from table A, and corresponding, 10 records from table B. The end result is that, the moment they apply where condition on table B, then only those 10 records or that one record comes up. So it's as equivalent as writing an inner join or interaction, and that's one of the most fatal flaws that I've seen, not just in interviews but in real life as well. A lot of people make these mistakes, and trust me, millions and millions of dollars are lost because of this. I've seen this issue creating, big time problems at Meta. I've seen the same mistake creating, big problems at DoorDash. And as I said, millions of dollars are lost on a daily basis because some coder somewhere makes this small tiny mistake, and it's very hard to catch sometimes, because you think like, hey, it's all good, nothing buggy, looks okay, works well, but it doesn't work well. So please save worlds, like millions and millions of dollars in future. Don't make this mistake. um, and Yeah, pro tip number two, kind of combination of a few tips. Don't use select star from whatever the table name. One of my colleagues did this back in Amex. When I joined Amex in 2011, I think, yeah, after a couple of years, I was already pro in SQL, but I remember my director back then telling me, like, just don't do this ever. And I was like, yeah, obviously I won't do it. But then around that time, a person joined in our US team, and she did it. Like, she was just exploring the data, and she did this, and the whole system got down. Effectively, think of it this way: select star from a table. So if you're extracting, star means all the columns, and you're just extracting all the data from a given table. And imagine a company like Amex, imagine, like, a table which stores all the transactions, credit card transactions, not just, like today, but like since the dawn of the time, like, I don't know, 150 years. Hopefully they had like systems since like 10, 15 years. So 15 years of transactional data every day. Every customer is, uses the card at least 3 to 4 times a day. And then it's like, I don't know, 100 millions of record, and suddenly she started printing them. So obviously, all the system choked, and always use the limit. So this is the first problem you can avoid and cause a scene on your job on day one. So avoid that. Always write limit. So always write select star from table name, limit 10 or 100. So only 10 or 100 record gets printed. Um, Second thing, I would say avoid writing unnecessary complex queries. I told this earlier as well, but over time I have seen, many people, even in interviews, even today, when I take interviews for DoorDash, and I see that a lot of people, very senior people, in fact, they do the right thing, but they just unnecessarily complicate it. And the problem with complication is that sooner or later you will make mistakes. Secondly, even if you don't make a mistake, people trying to learn from that will make a mistake. So always write in simple terms, always try to think like, a non-complex, easier way to do things among the available options. Obviously not always going to be possible, but with time, at least you'll learn that. And the third reason why it's very, very important is because as organizations scale, like for now, for example, my job is not to do one analysis, not to just, like support one line of business. I support like 8 or 9 lines of businesses in my role. And honestly, my job, is actually to figure out like how to find synergy across people. So if person A is working on something, how can I use that thing and help person B as well, and vice versa. And that's only possible if people are writing more efficient codes. So that's something always remember when you start your jobs. Like uh, maybe initially in the job it may not appear very, it may not be very evident that writing a simple query, why it is important, but sooner than later when you graduate in your career, you'll realize like how easily it is scalable if it's easy, how easily other people can perceive the value you're adding. So always focus on like simple things. And last but not the least, like null values, I know I called it out earlier as well. So null values are always like tricky. Again, similar to the left join problem, null values have also created variety of big problems that you will not imagine. Like what the hell, like this kind of simple mistakes have cost companies like millions and millions over time. And when we debug such problems, we just laugh at like ourselves, like what the hell, like and sometimes it's such ridiculous errors that it's and the analyst and the scientists are like have like plethora of degrees like PhDs and masters from all the MITs and Stanfords of the world, and then they make these basic mistakes, and sometimes it just becomes a fireable mistake. So as even leaders, we can't save them because it's like this is very basic. You made a mistake, doesn't really matter how many degrees you have. We have to let you go, and that's not a pleasant conversation for anyone. So again, avoid that. I know we are kind of on time, so that's all the content I have. I know I've been speaking for a long time, but I want to make sure that we make it as engaging as possible in the next 15 minutes. And all and any question I would expect, like I would be able, happy to answer rather. So I'll stop here. Go ahead, guys. Go crazy. Ask questions. Any and every question, I would be happy to answer. Okay, the first one who asks the question will get a special prize. I'll personally review their CV when they're applying for a job. So whoever asks the first question. Okay, I see Jain, data scientists versus data engineers. Uh, got it. So if I understand correctly, like you want to understand like what's the difference between a data scientist and a data engineer. Uh, so as a beginner from now, How can I learn? Okay, maybe I'll answer this one first. Jayant, definitely add me on LinkedIn, and I'm not sure which year you're in engineering or whatnot. I'll definitely help you in terms of reviewing your CV. Um, big companies like as I said, last 4 5 years I've been working in big tech companies, Facebook and DoorDash and so on. Here, the profiles are a bit more demarcated in a startup or in even in traditional companies that I've worked with, like consulting or Amex. Uh, Everyone was doing kind of everything. Like I was building the pipelines for data. I was also doing all the analysis in between, and I was also doing the ML modeling. In big tech companies, they have demarcated these roles more cleanly. So data engineers, their whole focus is actually to make sure the data is stored and munched and prepared, and handled properly. So as a data engineer, my job would be just to write the pipelines. And when I say pipelines, effectively there is a lot of raw data that gets captured. So how do you synthesize that data in a scalable way? And it's not like a simple table. It's like a table with like 100 million records, and then it has to be joined with 10 other tables with 100 million records on a monthly or on a daily basis. How do you do that in an efficient way? So data engineering is kind of a bit more of engineering, because you have to understand the systems, the processes, how exactly SQL works behind the scenes, and what kind of joins, what kind of operations would be less computationally expensive versus high computationally expensive. So data engineers are focused more on that versus data scientists. Data scientists are more business people. They don't really care much about the cost of running a query, because even if it gives like an answer in like 5 minutes versus 10 minutes, I'm fine. I can, I don't really care. I'll have that error of margin. I'll not be that efficient in writing my query as far as I'm getting the data right. So as a data scientist, I would focus more on getting the right data from the available data resources, and then using the data to make a decision, or to inform mathematical model. Even at times, data scientists. So think of it this way: data engineers' job is essential for data scientists, and data scientist's job is essential from an MLAI specialist, because machine learning engineer is gonna build an ML model, but which variables they are gonna keep, that's something will only come from data scientist analysis. So hopefully I'm able to explain this. In the interest of time, I'll go to the next question. Uh, as a beginner from non-IT, how can I learn? Okay, sorry. Uh, you don't have to be from IT. I have people, my colleagues are from all kind of background, like, economics, history. They all SQL experts. They all data science experts now with time. So it starts from the basics. As I said, SQL is simple language, like an English language. We just make it sound hard. It's not. I don't know why people do that. Like I always remember telling this to people that when I was preparing for IIT JEE, like a lot of my colleagues were do this book called Eurodo, and I never heard of that book. I never read that book. I never even saw that book. Um, I just focused on like HC Verma and some basic stuff, and then I still got like very good numbers in physics and whatnot. Because you don't have to solve the hardest of the problems. Sometimes solving the hardest of the problems would just you lose your confidence. It's better to focus on fundamentals. It's better to build from those fundamentals. Start building your understanding of complex things, and then solve those things one by one, rather than trying to solve a very very complex problem. So that's how I would say, like any language for that matter, whether it's SQL, Python, or even Java, nothing is tough if you start from the basics. SQL is probably the easiest. It's simply like writing as English language. So SQL Bolt, I think, is the best resource among the free links that I gave you. Start from the first. It is very well structured content. I have my one of my family members that I advised last year. He started learning from that SQL Bolt thing, and he liked it very well. He worked in a different industry for like 15 years, 10, 10, 15 years, and then he started learning last year. I think he was performing well within an industry, but like even after 10, 15 years, he was only making like I don't know 15, 20 lakhs, and He was really frustrated that his industry didn't really grow much. So he was trying to pivot, and he started from scratch. Within 3 months, he was able to learn SQL from those free resources. Um, Last I heard, like a few months back, he cracked the job in a startup, and he's making 2x than the salary he was making until last year in a non-tech environment, so non-IT environment. So it's possible. You just have to give it the right kind of a try. Okay, more like data engineers do cost reduction more, and data scientists are more focused on data insight. Yeah, yeah, you are absolutely right. That's what it is. Data engineers are focused more on cost reduction and doing things more scalably. Like I expect my data engineering team to actually like I've written some of the pipelines sometimes because I don't get all the data engineers in the world that I want, so I just write my pipelines sometimes. But whenever I get resources, I ask them like, hey, I want these data to be ready 9 a.m. Monday morning, so that I start my work. These data tables should be updated. So their job is more like to figure out, like, doesn't really matter how expensive the operations are. I want these things as a data scientist, so their job is to make sure I have these things, because then I can process that data, build in a dashboard, or build a model, and then find the insights and share with my partners, my leaders, and so on. Okay. Please tell us about your first job related in the field, the technical and soft skill bits. Even what are the things you would have done differently now that you're a senior? Great question, Parita. Really great question. So, um, my first job, as I said, was in a company called MarketRx. I mean, honestly, I was a recession graduate, so I didn't have many options when I started. And MarketRx was like, the only option I got. It's a day 5 or day 6 company in IIT Kanpur those days. Um, yeah, I was among the top 50 people to get placed from my batch, but of out of like 500 people, like top 10%. But it took me like day 5th or day 6th to get placed. MarketRx was a great starting company. First month or two, they had a well structured training program conducted by a 1 year senior. Um, the technical skills were very easy to learn, like Excel, PPD, SQL. I think I just took probably couple of weeks to learn the basics and fairly advanced versions as well. And then you have a lot of codes from seniors, a lot of processes already built in. So you can just learn a lot from there. Like, hey, what are they doing? What is the existing code doing? That's probably the best way to learn. Like if you already know that this is the outcome and it is produced by a certain set of code, you just go through the code and understand like, okay, what this function is doing, what that function is doing, and so on and so forth. So that's how I learned the technical part. The soft skill part, honestly, so I don't think I would do differently anything on technical side. But yeah, soft side, I would do a lot of things differently, so that where I am after 15 years, even though my friends, my colleagues, my family feels like I've done very good in life. I think I could have done it, probably 5 years earlier if I had focused on my soft skills earlier. Uh, and that's true even today. Like, so my focus last few years have been only on soft skills. For all of you, just focus on the way you present yourself. Just focus on being attentive in the interviews. um, Focus there. Again, soft skill is a very one word for a lot of variety of skills that you have. And probably today we don't have enough time, but if you ask me, yes, I would have done very, very different things from soft skills point of view if I would start today. All right, say so data is stored in tables. How is data collected, clean? Uh, Graphs in Python are built. Um, Okay, so in one line, like, again, every company is different. So it's really different how things are done across the board. Looks like you have some sense like how things are done, but it's it's like an ideal version of the world. Like that's how the things should be done. And then there's like real version of the world where, like, what, I just have to build a model where I have to predict, like, okay, who are the executives in a given company. So I'll just hire a couple of analysts in India, ask them like, hey, look at like 300 companies and 300 executives, like CXO profiles, like VP plus, and give me a 10 tag and some information from LinkedIn. And then I'll have other team to extract data from LinkedIn and just merge these two data and then figure out like, okay, I have my 10s, and then I'll just build a ML model to figure out which one is the executive, which one is not. Why is it important? Because my partners are building some special credit card for like executives in a given, in corporate world. So I'm just giving you real life problems. Uh, Real life problems have a real life solutions. Yes, they can be scaled. Yes, they can be very clean. But many a times you'll have like, messy things in between. And that's the nature of the world. And you have to just embrace it at one point. But yeah, in an ideal world, SQL is used a lot to clean the data, store the data efficiently, power a lot of dashboards, and so on. Python is used to, predominantly. I haven't seen Python is definitely used in automating some of the ETLs in some of the data engineering stuff. I haven't seen much of the visualization or dashboarding using Python. I will still see like SQL being the main language there. But yeah, when you're building a model, Python is essential. Like all these MLA features. Like I started my career when Python was like in its infancy, and we used to build models in like SAS and SPSS and whatnot, and it used to take us like not even weeks, like months to build a model. Now you build a model in 2 hours, or maybe less, if you have that reasonable data. So uh, definitely world has changed. Python is very, very useful for ML and AI and all that machine learning aspect of things. SQL is more fundamental that everyone should know. All right. Do preparation for data scientist role DSA skills necessarily? If so, um, yes and no. I mean, as I said, like for a data scientist role, again, ask the company, understand the JD, like what exact requirements they have. I can give you an example of the companies I have worked with, like DoorDash or Google, Uber, because that's where I've mentored my colleagues and friends, or DoorDash. They only conduct SQL interview for a data scientist role from technical point of view. Generally, they are just one SQL interview and one case study. It's like a consulting case study. You clear those two, and then you are in for a full day interview. So, and then in full day interview, there is no technical round. There are just three case study rounds, similar to like any consulting firm. So even as a data scientist, I cleared like for entering into Meta, I cleared like four case study rounds, business case studies, and one SQL interview. That's about it. So those are all the skills that were required. So you can say like a lot of people thought like, oh, you're going to Facebook. Facebook might require you Python or machine learning or AI. They didn't even ask anything. They're like, fine, okay, they were just looking for raw IQ. They were just looking for how good I am at solving ambiguous problems, putting structures to things, and how open thinker I am. And obviously, they wanted basic SQL, like not basic, I would say advanced SQL skills. Uh, so yeah, as far as you have them, I think you can crack most companies. Okay. I know we are on time. I'll still go through one or two more questions. Which is the best ATS platform? Sorry, I'm not aware of that. Uh, there are thousand ways to make money. Why should someone choose this way? I understand that is not completely about money, but its majority is. Good question. Like, I honestly uh, uh, don't know about others. I know about myself. Like, there are definitely thousand ways. I have I have thousand friends, and all of them make way more or way less than me, depending on the trade they are in. Um, I chose it because I like math. Although I get bored with doing one thing, data science as a work stream or analytics as a work stream is kind of in between everything. It has a bit of engineering, bit of business, bit of coding, and bit of consulting. So this kind of appealed me a lot, that you have to have like some of everything. And depending on the day, depending on the context, you have to bring a different version of you. And it pays well as well. So why not? And then I don't have to like kill my rest of the life like in iBanking or consulting. So ROI wise, I think it's better. So I chose this way. But obviously, everyone chooses differently, and it is fairly possible. Like everyone can have a different path. All right. Sorry, I'll have to stop now. Uh, but yeah, Ishika or anyone wants to take it over. But those are all the questions I can handle. My LinkedIn is open. Feel free to add me there.
Yeah, so it's time to conclude the session. Thank you, Rajil sir, for sharing your valuable expertise and insights on SQL and its role in business analytics, and also for guiding us so effectively. And also thanks to everyone who joined today for your active participation. We will be concluding the session now. So that's it from Consulting and Analytics Club.
Thank you, Shika. Thanks everyone for joining. Have a good one. Bye bye.